Let us understand how to manage partitions using table users underscore hash underscore part, which is partitioned using hash. We would like to divide our data into 8 hash buckets. While adding partitions for hash partition table, we need to specify modulus and reminder. We will look into those details in a moment. For each and every record inserted, following will happen for the column specified as partitioned key. In our case, the partition key is nothing but user ID. Whenever we try to insert data into users underscore hash underscore part table, the user ID will be used to decide which partition the record should get into. Based upon the values that are generated for user ID, a hash will be computed. Hash is nothing but an integer. I would highly recommend you to spend some time to understand about hash if you are new to it. If you are already familiar with it, that is fine. Otherwise, you should spend some time in understanding the concepts related to hash by googling around. In this case, for each and every user ID, a integer based hash will be computed. The integer which is generated will be divided by the value specified in modulus. Modulus is nothing but some number. It can be 8, 16 or whatever number using which you want to divide the data into different buckets. In our case, we want to divide our data into 8 buckets and hence modulus is 8. When you divide a number with an integer, it will generate a reminder. Based upon that reminder, the record will be inserted into corresponding partition. Let's look into these details in action so that we understand the concepts around the modulus, reminder, and how the data will be loaded into specific partitions. So in this case, I am actually loading SQL Magic, then creating the database URL environment variable. When it comes to tables with hash partitioning, we cannot have a default partition, and hence if you try to run this command, it will fail. You can see that it throw an error saying a hash partition table may not have a default partition. Now let us add partitions using modulus as 8. For each reminder between 0 to 7, we need to add a partition, and this is how the syntax will look like. You have to say create table, the table name for the partition, then partition of main table as we have seen with list and range. Then when it comes to adding partitions for a hash partition table, you have to use for values with. With list it is in, with range it is from and to, with hash it is with. Once you specify for values with, you have to have modulus and reminder like this as part of the circular brackets. Modulus is nothing but number of buckets we want to divide our data into, and hence modulus is same for all the create table commands here while adding the tables for supporting the partitions. And then for each reminder, we can have one table. So in this case, we are saying create table. Table name is users underscore hash underscore part underscore reminder, which is 0, and then of 8, which is modulus. So this will take care of creating one partition for us for reminder 0. This will take care of creating another partition for reminder 1, for reminder 2, for reminder 3, 4, 5, 6, 7. We have all the 8 partitions starting from 0 to 7. Now we can insert the data into this table users underscore hash underscore part. User ID is populated by sequence. The hash of every sequence generated integer will be divided by modulus, and based upon the reminder, data will be inserted into corresponding partition. In some programming languages or technologies, when it comes to hash on an integer, it typically returns the integer itself. But with Postgres, it is not the case. The hash of even an integer can be a different value than the value itself. Let's see in action so that you understand. For now, I'm just running the query select star from users underscore hash underscore part, which is the main table. There are 3 records in this. Now I have 8 queries, one against each of the table which is created to support each of the partition. When I run the query against 0 of 8, you can see there is one record with user ID 1, which means whatever hash value that is generated, which is nothing but an integer, is divisible by 8. That's why we got the reminder 0, and the record is inserted into this table which is created for reminder 0 when the hash value is divided by 8. When it comes to user ID 3, the hash value when it is divided by 8, the remainder is 1. That's why it got into this table. Now when it comes to user ID 2, when it is divided by 8, when I say when it is divided, it's not the 2 itself, it is the hash. So whatever integer that is generated as hash for the 2, when that integer is divided by 8, the remainder is 2. That's why it got into this table which is for remainder 2, and hence we are seeing this record here. As we got all the 3 records in the first 3 partitions, when you run these queries against the other partitions, you will not be seeing any data, and hence you are just seeing the message 0 rows affected for each of these queries. Now this is how you can add the partitions. If you want to drop the partition, you can drop the table directly, or you can detach the partition and can drop the table. Either approach will work. However, with respect to hash partitions, it's not a good idea to drop the partition. For each and every reminder, we should have a partition associated with it, because we don't know what value we'll be using to compute the reminder, as hash can be anything based upon the underlying algorithm. If you are interested in internals, you can explore it further, but just first understand the concept of hash. You don't need to worry too much about how Postgres deals with it. Keep in mind that when you are creating a table with a hash partition strategy, you have partitions for each and every reminder based upon the modulus, and don't drop the partitions if they are empty. Just leave them like that, because when we insert the data, it can be any hash value, and based upon the reminder, it can go to any hash partition. If you don't have all the partitions based upon the reminders, then you will start seeing errors as part of your application. So this is all about managing the partitions for hash partition table, and also how to get data into that table.